Good morning, everybody. Welcome to exciting morning of Chem 1105 with your host, me, Dr. White. And if you're not here, you're watching me on video. All right, a couple of things. This semester, you'll learn a lot about Dr. White, and it just comes out when I lecture. Now, one of the things I have to tell you is I have a hearing problem. If we were face to face, you'd see me wearing my hearing aids. Nope, I don't have them because we're on Zoom. I have two huge, large amplified speakers that are turned up. Now, what that means is if you ask a question, I still might ask you to repeat it once or twice, even with the speakers. So let's wait a second while people are showing up. Maybe 2 seconds. If you can, turn on your webcam, makes Dr. White happy. All right, so as I was saying, you'll learn a lot about me. Like I said, I have a hearing problem, but with my amplified speakers, I don't wear my hearing aids. If we were face to face, you'd see me wearing them. But if you ask a question, I might ask you to repeat it once or twice. All right, now, probably the most important thing I will teach you today is the following, and listen carefully. In my class, in my world, there's no such thing as a dumb question. I'll say it again. In my class, in my world, there's no such thing as a dumb question. I learned that lesson my second year grad student, I think it was second or third year, from a postdoctoral fellow in our research group. By the way, I got my PhD in chemistry from Michigan State University. And I was giving a talk in our research group about my research. And Dr. Plavin, hold on, let me just do one thing. Okay, for those of you using closed caption, feel free to. But anyways, he asked me, I talked about, he said, what's the mechanism of that reaction? That was a key reaction I was talking about. And I showed him. And afterward, I went up to Dr. Plavin. Here's somebody who already has a PhD in organic chemistry. And I said, Larry, that's his first name. I still remember this for years later. Weren't you embarrassed asking that question about the mechanism? That's something we teach undergrad organics. And he said, why should I be embarrassed? I didn't know it. I asked the question. Now I know it. And at that point, I started realizing, getting it into my brain, there's no such thing as a dumb question. So in my class, in my universe, there's no such thing as a dumb question. Always feel free to ask questions. Do I know the answers to everything? No, but in the chemistry I'm teaching here, yes, most of it. If not, I'll tell you and I'll find it out. All right, another thing you'll learn about me is I teach by my golden rule of teaching. What's that? And it is, I don't do to my students what I didn't like done to me as a student. By the way, yes, I was a student long ago in a galaxy far, far away. You know where I stole that from. And I got my notes here. So we'll do that. Now, one of the things I've done a couple of years ago in general chemistry, I teach here at COD, College of DuPage. I also teach chemistry at Elgin Community College, ECC, is I've cut down way down on the memorization. You still have to learn how to do things, but I've cut down the memorization, and you'll see that. All right, one admission I need to make. I have taught 1105 a number of times, both face-to-face and on Zoom. But the ones I've taught have either been the 16-week or the summer 8-week. This is the first time I've taught the 12-week. There shouldn't be any problems. The only thing is, when we get to my syllabus, some of the test dates and the dates when I cover things probably might shift a little, because I'm not used to the timing of 12 weeks, and I approximated what I think should be right, but that sometimes changes. Oh, I should mention, I'm coming from COD North, my office in Schaumburg, and my home. If you notice some of my hobbies here and here, this is my office. All right, let's get started. Let me find what I'm looking for. Ah, that's not what I want. That's what I want. All right. One of the things I'll ask you is give me a thumbs up with your emoji, or turn on your webcam, do a thumbs up. Everybody see Blackboard on your screen right now, where you see College of DuPage. Can you see that?
Yep, I can see it.
Okay, thank you. All right, now here's our course. If you notice, thank you, George. You'll notice I have my email and also announcement I sent out. All right, if you look over here, we have announcements, assignments, course information, and syllabus. I'll talk about later my YouTube channel. Do you know I'm a YouTube star? Not really. And because there's a little difference in our ages, a couple of years ago, I started posting some of my favorite music, movies, and books. Because of the generation gap, a lot of you didn't know the good stuff. Sorry about that. It's my phone, Bluetooth. 3 more rings. 2 more rings. That should be the last one. Sorry about that, but that's my Bluetooth. Be quiet. Thank you. It wasn't the President of the United States, or I would have answered that. All right. Now, here are different things, and I'll talk about this. Let's go. If you open up click on syllabus, you see my syllabus, and let's talk about the syllabus. All right, thumbs up, people. Does everybody see my syllabus? The reason I'm doing that is Zoom has a habit of telling me you see it and you don't. So that's why I do it. You should be seeing it. All right, here's the syllabus. I'm going to go through some of it. This is not the most exciting thing in the world, but it's important. All right. First of all, I'm Dr. White. Here's my email address. Now, here we have, thank you for turning on your webcam. We have on Monday and Wednesday from 10 to 11:45, and we will take a break, 5-minute break. I have optional lecture. On Tuesday, we have both the discussion and lab, and that goes from 10 to roughly 12:30. Yes, we will take breaks. Now, here I have the Zoom login, which if you're here today, you know you've been able to successfully log in. Good thing. Now, I'll also have office hours on Zoom. Right now, I have them scheduled from 6 to 7:15 on Tuesday and Wednesday. And here's the link to do that. Now, I don't even know if I put it in. Oh, yeah, up here, you see the office phone here. This is really a voicemail box. And I have to think about what year I last checked it. It's been at least 5 years. The best way to reach me is by email. My email address is here, whitek@COD. I check it twice a day, every day of the week, Saturday and Sunday included. And I'm an early riser, so in the morning, usually by 6:30, I've checked it AM, and in the afternoon or evening, I'll check it a second time. Now, I'm gonna skip the catalog description and the objectives. This is stuff and the active course file. All faculty members teaching this course have to put this in their syllabus. All right, let's talk about some important things. One is the textbook. Here's the name of the textbook. And here's the textbook. Now, I make it optional. In other words, you don't have to buy it. I would recommend highly you don't. Why? Because I have found over the years teaching this and other class I teach, the way I lecture, my lecture slides are in Blackboard. I should warn you, at the other school, their online computerized system, like Blackboard, is called D2L. Sometimes I get the names changed. I say D2L instead of Blackboard. I'll correct myself. But anyways, I also, and you'll see in a little while, I have recommended practice problems. You'll understand after test one why I call them practice problems. Hint, hint, wink, wink, hint, hint, say no more. That comes from Monty Python. But anyways, you don't need the book. And I also have the answers to the recommended problems. And don't buy it, because if you buy it, the bookstore doesn't want to return it because they say, well, it should be, you should buy it. So just, or I mean, maybe first week be able to get return it. All right, the next thing for this class you'll need is the lab kit, and it's required. You get a voucher from COD bookstore, and then once you get the voucher, you can log on. Here are the steps to do it, to redeem your voucher and get your lab kit. You'll be doing labs at home. And last semester, I used a similar lab kit for Chem 1211. Excuse me. And it was a really good lab kit. It is a really good lab kit. But you need to do it. And this semester, excuse me, COD has instituted a Chem department that you're not going to pass if you don't buy the kit and do those labs. Last semester in some of the classes, students were faking it. And the chairman of the department set this out. All right, my attendants are, first of all, you'll need a calculator. And I would highly recommend this Texas Instrument calculator, the TI-30XIIS. And here it is, live in person. And I will teach you how to use this for scientific notation. Anything we do in this class, anything I put on a test, I'll teach the concept behind that question or how to use the calculator to do those calculations at least twice in my class, usually a lot more. All right, I have a thing about student behavior. You're supposed to follow the academic code of academic conduct. Here's the link to the PDF file of that. And please follow it. Here's some things you should not do. And some more things. I'll let you read that. Please be polite in my class. This stuff about behavior is more for face-to-face. Cheating, please don't. Even though we're online, I have things in my test that tell me when a student cheats, and I will follow these things in my class. If you do cheat, please don't. You should prep for my class, like doing the practice problems. Now, this is very important. And if you are a special needs student, either email me or see me in private. I work with the Center of Access and Accommodations to meet the needs of any special needs students. I've been working with them for many years. I've had a number of students who have had special needs, both online and also face-to-face. I've done it. So if you have special needs, let me know, and I will help you any way I can, and also work with the center to help you any way I can. All right, some important things. First of all, there's going to be 4 hourly exams. Here's the tentative date. Because it's the first time I've taught a 12-week, I've done 8 and 16, I guessed at what it should be. And the reason I say tentative date is I might change this where I figure, let's give it a couple extra days so I can do another lecture to help the students, so things go well. I'll talk about this, about regrading, once we get it later in the semester. There'll be a final exam. It will be given over a 24-hour period because this is during finals week. Normally, if we're face-to-face, we would have a date and a final exam schedule when we'd have our final exam. NET doesn't have an exact one. I'll have some extra credit during the semester. I'll talk more about it. If you need a makeup pal because you can't take an exam, let me know and we'll work something out. But I will need some sort of doctor's letter. All right, what's important to you? How do I get a good grade in my class? Well, we're going to have 4 tests. What I do is I take each one's 100 points. I take the sum of the highest 3 hourly exams out of the 4, and that's worth 58% of your grade. We'll have a final exam. That's worth 19% of your grade. And the labs you'll be handing in, I'll explain that in a little while, that's 23% of your grade. Now, your percentage will be calculated by the sum of the 3 highest hourly exams, the final exam score, your lab total, plus have an extra credit project. Multiply that times 100, divided by 520, you'll get a percentage. If your percentage is 90 or greater, you get an A, 80, 89, B, 70, 79, C, 60, 69, D, and less than 60, F. Now, the way I teach, and I've been teaching this a number of times, 1105, and other classes I teach at COD, historically, which means that usually happens if you follow what I recommend. Usually 60, 65% of my class, listen early, earn A's. Yep, earn A's. And most of the rest are B's and C's. I rarely have people flunk, but I do. There's only so much I can do. You've got to do the work also. And here's the withdrawal policy. It's totally out of my hands. It's done by the administration. And here's the last day to withdraw. I can tell you this. I think over the last number of years, maximum, I might sometimes have one person drop. In other words, 99% of my students finish the class and they do well. But if you are planning on dropping or withdrawing, by not showing up or doing the exams or labs doesn't constitute officially withdrawing. You have to go through this, through the registrar, and withdraw that way. By the way, going through the syllabus isn't the most exciting thing in the world. Sorry about that. I clicked on the wrong button. That happens. All right, here we have our tentative schedule. This week, I'll be going through chapter 1 and appendix A2 and A4, and you'll see the rest. In red, I have the days of the test. I also had a date earlier. And the tests will all be on Wednesdays except for the final. And the Monday before, or Tuesday, I will do a review. And that review will also be posted. And here's this. All right, let's go on to the lab. We'll be doing a lab, or you'll be doing the lab at home, and the lab kit is pretty good. Now, one of the things the department has instituted is this right here, that when you do each lab, you'll have to also include a selfie of you and something from the lab you're doing. And that's so students don't fake it. Also, you have to upload a safety sheet signature for the distance learning safety agreement. And I'll talk more about that tomorrow when we talk about lab and do our first lab. And each lab is worth 10 points. We'll have 13 labs, and I take the total of the top 12. And that's 100% used toward your grade. Now, lab reports are due the session after the lab report being handed in. What that means is tomorrow you're going to do a lab. Now, if you don't have your kit yet, tomorrow's lab is the only one you don't need to get. I highly recommend you get your kit ordered if you haven't as soon as possible. Now, the lab we'll do tomorrow, the safety lab, will be due a week from tomorrow. And if your lab is not handed in the lab report, you get 0 points. If you're late more than 1 week, you get 0 points. In other words, hand things on time. Here's the tentative lab schedule. And I'll talk more about this tomorrow. Now, the final thing, I have what's called a student agreement. There's a copy of this in the syllabus, and also I'll show you in the assignment area. And this student agreement essentially says, part of it, you've read my syllabus and you understand it's your responsibility to abide by the policies, and you understand if you don't, that failure to abide by the policies will result in the consequences outlined in the syllabus. Now, it also says I will be, which I'm doing right now, taping all our Zoom meetings. And I'll be posting these meetings on my YouTube channel. And therefore, you waive your FERPA rights concerning your name, voice, or image appearing in these videos. And here's the sheet, and I'll show you in a second where you can get it. And I won't consider you an official member until you have signed and uploaded this agreement. And if I don't have it by the first test, you'll get a 0. You won't be allowed to take that test. All right, now if we go into Blackboard, see on the left where it says assignments, I'm going to click on that. In fact, let me do something real quick. I'm going to go to student view like you would see it. Click on assignments, and you'll see the signature sheet. I have it both as a Word document and a PDF file. Now, I also have instructions how to submit labs or this and tests as a single PDF file. I have it in two different ways, a Word and PDF doc. Now, good news, if you don't have a scanner, those files teach you how to use your cell phone. I think just everybody in my class has access to a cell phone or has their own cell phone. If you take pictures of whatever you're handing in, those two files tell you how to make them into a PDF file. It's not that hard. One of the things I learned a couple of years ago from students, a good way is to use the phone app called CamScammer. And I have a PDF file and a Word document about CamScammer, where to find it. Do not spend any money on it. Use the free version. You don't need any of the bells and whistles to get with CamScammer turn pictures that you take with your cell phone into PDF file that you can upload for my class. So get the free version. Don't waste your money on any apps or bells and whistles that app. And with that, I'm done with the syllabus. Any questions? Also, feel free to use the chat, even though sometimes I forget to look at the bottom. Any questions on the syllabus? All right. All right, thank you, Katie. All right, let's talk about how do you do good in my class? Well, in order to learn how to do good in my class and learn chemistry, let's talk about bicycles. Bicycles? Yes, bicycles. Let's assume you don't know how to ride a bicycle. And being the nice person I am, I give you the best Blu-ray disc on how to ride a bicycle. And you've got a monster 85-inch large screen high-def TV, and you have a really nice Blu-ray player. You put the disc in there, and over the next month, you watch that. You do it slow motion, frame by frame. You back it up and watch things over and over again. And if you don't know how to ride a bicycle, even though you saw that Blu-ray, so you knew every frame by heart, what's going to happen the first time you get on a bicycle? You're going to fall off. But when you practice, you get better and you learn how to ride a bike. Well, learning chemistry with me is the same way. You'll see me doing problems. And when I do it, wow, it doesn't look too hard. But just like the Blu-ray, how to ride a bicycle, if you don't practice on the test, guess what? You're going to fall off, which won't be pleasant. So I'm going to remind you, even though you watch me do it, I have set up in Blackboard practice problems. Do the practice problems on your own. If you have problems, come to lecture. If you can't make it to lecture, come to my office hours, or if it's really you need help, email me and I'll see if I can set up on Zoom a time when we're both available. I should say this, I said you learned stuff about me, personal stuff. And one of the things personal about me, Dr. White, is I'm a very selfish person in one way. And that one way is I like things to happen around me that make me happy. And one of the things that makes me very happy is seeing my students succeed. I get no pleasure seeing somebody flunk. Actually, it makes me feel sad. You know, I wish I could have done something to help them more, but some things are out of my hands, which means practice. All right, any questions? All right. And we'll talk about other stuff, the safety contract tomorrow. All right, if you look on Blackboard, you'll see I have here course information. If you click on that, everybody see and give me a thumbs up with your emoji. Do you see lectures folder, recommended problem sets, and recommended problem set answers on your screen? Now, give me a thumbs up. All right, I assume you can. And if you click on, thank you, Katie, or Yasmin, I'm sorry. And if you click on lectures, you'll see a lot of lecture files. Now, what I've done is each file I have here, I put both as a Word doc and a PDF file. And here's chapter 1, chapter 2, and we'll also go this week appendices A2 and A4. Well, let's get started. Oh, wait, I said, thank you. And anything, and let me open it. One thing, anything you see on the screen here that I put on, other than my writing tablet, which you'll see I have a tablet, so it's like I'm writing on a whiteboard in a classroom, is available as a file. All right, it's time to begin your journey into my world of chemistry, which is really your world of chemistry. But before I do this, I like to do one more thing. Why learn chemistry? That's a good question. Why learn chemistry? Well, inhale, exhale, blow on your hand, do it. Feel that? Those are molecules of nitrogen, oxygen, and that's chemistry. The next time you're outside and you feel wind on your face, those are molecules of oxygen, nitrogen hitting you very quickly. And that's chemistry. If you look at my shirt, that's made of molecules, that's chemistry. The water in my bottle, that's chemistry. This wall, let's see, right here, that's chemistry. The plastic, everything around you. So everything is, well, I'm biased, is chemistry, mostly, maybe not the light. You can say that's physics. But you could also say that's a branch of chemistry. So why learn chemistry? Because someone told you needed this class for a requisite to get into school or program. I know that. I know that about you. So I'm not going to try and turn you into a chemist, but you'll find out my world of chemistry is really your world of chemistry. I should mention, I have a PhD in synthetic organic chemistry, and for many decades, I worked as a senior research and development manager for a number of international chemical companies. By the way, I got to spend a lot of time in Europe, especially the Netherlands, Germany, and England. All right, let's get going. What's chemistry? Chemistry is the study of the composition, structure, properties, and reactions of matter. Now, throughout the semester, I'll do the following. Click, the switch is off. This won't be on a test, or I'll remind you, you should know this. And for this slide, click, it won't be on a test. I'm never going to ask what's the definition of chemistry, but I think it's something you should know. So chemistry is really the science that tries to understand how matter behaves by studying how atoms and molecules behave. And by understanding that, we can do that to make things that we use in our daily life. I have 10 US patents. One of them is for a molecule used as a fabric softener. And my knowledge of organic chemistry helped me develop that. All right, now when we talk about chemistry, there are four main branches of chemistry. Now, one of the things I like to do is the following. I like to be subtle. One thing I pointed out about 2.5, 3 years ago, I found out most of my students can't read cursive. Therefore, guess what? I'll print things. All right, let's talk about the four main branches of chemistry. The first one is organic, but that's the best because I'm an organic chemist, so I'm biased. Inorganic chemistry, physical chemistry, analytical chemistry. You should know the name of at least one of the four branches of chemistry. Organic is the best. And organic chemistry, and we'll do some, I'll be teaching you some later in the end of the semester, deals with molecules that originally came from things were alive. And that's been expanded to things, molecules that have carbon, hydrogen, and other atoms. Now, inorganic are originally molecules that come from things that weren't alive, like rocks. And physical chemistry investigates how atoms are set up or exist, and molecules, what are key forces. And finally, analytical chemistry is how you measure things, and they develop things to measure properties of chemicals. If you've ever seen a CSI program, which I don't watch, but are quite popular, the scientists in those CSI programs are really analytical, most of them analytical chemists. So you should know, if I ask on a test, name one of the four branches of chemistry, you should know how to do that. Oh, it says it on the top. And organic is the best, but I'm biased. All right, switch is off, but I'm going to use these terms. What's a chemical? Let's talk about chemicals and substances. A chemical is any matter used in or produced by a chemical process. And I'll teach you later on what's a chemical process. Now, you'll also hear me use the term substance. That's a chemical that consists of one type of matter that's always the same composition and the same properties wherever it's found. Now, an example of matter, which is a chemical, is water. Water, which I'll teach you later on, some of you already know this, has this formula, and I'll teach you what this means, but I'll say now water is always 2 hydrogen atoms and 1 oxygen atom. And I'll bet most of you, next time you have a drink of water, don't consider that's a chemical. It's a substance. So I will use these terms, chemical, substance, and I use them interchangeably. But I'll never ask on a test, what's a chemical or what's a substance? Now, I've been talking about chemistry investigates matter. Well, what's matter? Matter is anything that has mass and occupies space. Click, switches on, you should know this. And mass refers to the amount of matter present. So if we look at water, it has weight, mass, and it's occupying space right now. So that's matter. So are you, but you're made up of a lot of complex, different types of matter. And it's another word for all the substances that make up our world. The oxygen you're breathing, that's matter. If you had sugar, you put in anything, that's matter. So matter refers to anything that has mass and occupies space. Now, when we study matter in chemistry and other also branches of science, but I'm a chemist, so I'm going to talk about chemistry. We use what's called the scientific method. Switches off, click. I will never ask you on a test what's the scientific method, but I would like to discuss it. And here, the scientific method, you observe something. And when you observe something, you collect measurements of some event in nature. If I were to take my water bottle, and I need a refill soon, but anyways, if I were to take this bottle, this water, and put it outside on my back deck of my house and come back tomorrow morning, and if the temperature went below 32 degrees Fahrenheit, 0 degrees Celsius, instead of being a liquid, it would be a solid. And that's the observation. And after collecting at different temperatures, I'd come up with what's called the hypothesis. And that's interpretation, a possible interpretation of the observations. Now, I forgot a dot. IE is Latin for that is, and I use it. That is the data, what you collect observations called data. And you do some experiments. I could take water and put it in different temperatures and see one's at a liquid, one's at a solid. And after I look at the data, I would come up with a theory. And that theory is when the temperature of water is below 0 degrees C, it's a solid. When it's above that temperature, it's a liquid. All right, one of the things I mentioned is that I've cut down on memorization, but there are a few things you will have to memorize. And I have found the best way to memorize things is to write something down on a piece of paper and then say it, and do that 5 times. Now, one of the things I will be asking you to memorize is the periodic table. And the periodic table deals with chemical symbols. And chemical symbols are 1 or 2 letter abbreviations for the names of the elements. And I'll teach you what an element is later in the semester in about a couple of days or a week. But example, oxygen, carbon, gold are elements. And only the first letter of an element is capitalized. If there's a second letter, then it's lowercase. Now, I'll never ask you what's the definition of a chemical symbol, but now you know what I'm talking about. Now, the periodic table has a lot of chemical elements in it. Here's the periodic table I'll be using, and you'll use this when you take a test. You'll be able to download this as a PDF file. And notice it has the chemical symbols, but not the names. Part of this class, I want you to learn the names and chemical symbols for the periodic table. But relax, take a deep breath, let it out, take a deep breath. Are you relaxed? I'm not going to ask you like some instructors to learn the whole periodic table. I don't. I know most of them. I'm only going to ask you to learn these 37 elements. What do I mean by that? You should know H is hydrogen and Ca is calcium. Also, one of my favorites, C over here is carbon. And let's go to the high price district. Au is gold, Ag is silver. Now, I'm not going to ask you to learn all 103. I think it's actually more now in the periodic table, because some of those I have never used, and I've been working in chemistry for decades. You will not use, by the way, I still consult besides teach. You will never use down here, number 103, Lawrencium. I won't either. But the ones I've asked you to learn on the periodic table, you need to know. Hint, you need to know it. How do you learn that? Write down the chemical symbol C, carbon. Do it again, say it, C, carbon. Write it again, C, carbon. Do it again. And if you're in the library, say it silently in your head. If not, say it out loud and write it, C, carbon. And you do this 5 times. And then another day, do it again 5 times, and you'll have it burnt into your brain. It works quite well. And flashcards don't work as well as this method, but if flashcards work for you, go ahead and use them. If I looked at the clock, it's time for a 5-minute break. I'm going to take a 5-minute break and get a refill and also stretch. And I'll see you in 5 minutes. Time to get going. Welcome back. All right, welcome back. Let's continue with Chem 1105 with your host, me, Dr. White. Welcome back. All right, one of the things during the break I forgot to talk about is the following. All right, does everybody see my YouTube channel? That really good-looking guy on there? And here I have a couple of semesters of 1105. And you can go back if you want to get, I have them listed by week. And if you look at the file name, it's year, month, day. Then at the end, I have what week it is. Now, this is I have for summer, I believe. I know I have fall, spring, a couple of them here. And if you click on the video, if you look under here where it says show more, you'll see I have what's covered in that video. Now, I'll be doing that for this class also. And within 24 hours or less after a class like today's, this will be here. And tomorrow, by tomorrow morning, probably late tonight, hopefully, you'll see 2023 0220, and it'll be week number 1. And here I am. Now, another thing I want to mention that over the last number of years, some of my students have had a serious problem, and that's called test anxiety. They do all the practice problems, they work hard, they take a test, and I'm a chemist, not a psychiatrist or psychologist, and their brain goes, ugh, and they just do badly on the test. Well, a number of years ago, I had a student the first time I realized that, and from a book I read, I came up with a method that eliminates test anxiety. And this Wednesday, I'll teach that method. Now I'm going to cut it out of the video. How do you like my special effects here? Anyways, I will take the part where I teach, I could call it the method, out of that video and post it as a private video on my YouTube channel, and I'll send out the link via email. I just don't want it floating around the internet for everybody. Maybe someday I'll try and sell it. Let me see, I got a refill. All right, we're talking about the periodic table, and you need to know, hint, you need to know this. Let me be subtle again. See how subtle I can be? Now, what does that mean? You need to know this. On a test, I could ask a question, 1 or 2 points each, or 3, probably 1 or 2. Give the chemical symbol for sodium. And you'd write down Na, because you learned Na is sodium. And I could ask also, what is the name of the element Hg? And that's mercury, because you learned Hg is mercury. Or I could have asked, what's the chemical symbol for oxygen? Oh, and those are questions you should be able to answer for test 1, because you've learned the chemical symbols for only these 37 elements. Now, let's continue on. I better be subtle again. And let's talk about the states of matter. But before I do that, let's just go back to the book. If you buy the book, which you don't need, but if you buy the book, you'll find I am covering the chapters in the book. The chapters, but because the book is, well, the book, I'm not going to say anything too bad about it. But anyways, the book, I have changed the order of some of the chapters because it doesn't make sense the way the author's done it. So I'll follow what's in the book, and sometimes I'll add some more because I've worked in the real world and I've taught this class, and that will help you learn chemistry. All right. And again, this is in chapter 1 of your book, but you don't need the book because I'm going through it. Now, there's states of matter, and you could also call it the physical states of matter. Oh, I do have it here. And the first one is called a solid. And you should know these physical states, and you should know a solid has definite shape and definite volume. Again, a solid has definite shape and definite volume. What does that mean? I got some good stuff over on the shelf here. Here's one of my favorite things. And this is a red sphere, and it's a solid. Yep, sounds like one. If you were to come back tomorrow, it would have the same shape and the same volume. How much volume space does it occupy? So you should know a solid, by the way, my favorite color is red. If you don't believe that, here's another thing above my desk on the shelf that I like to look at. And another one, and they're all solids. So you should know a solid has definite shape and definite volume. Next, a liquid. A liquid is something that has indefinite shape, but definite volume. What's that indefinite shape mean? Well, in this bottle, you can see it's a liquid. How do I know it's a liquid? Well, it's got a certain volume, definite volume. How much is in there? When this was full, which is not, it had 700 milliliters. That's a measure of volume in it. Doesn't anymore, and I reuse these. Don't look. But anyways, what's indefinite shape? Well, if you notice, the liquid inside is the shape of a bottle. If I were to pour this into a glass, which I don't have one right now, but if I did, the liquid, the water, would take the shape of a glass. If it's round, or I haven't seen one, but if you had a square glass, it would take that shape. And that's what liquids do. A solid wouldn't, because it has a definite shape. It doesn't change. If I were to put this in a glass, probably wouldn't fit. If it did, this isn't going to change its shape. It's a solid, but a liquid does. So a liquid, you should know, has indefinite shape, but definite volume. And the last physical state of matter, you should know, is a gas. A gas has indefinite shape, indefinite volume. So a gas is something, if I were to put it in a container or wherever, it would fill it up totally, indefinite shape. But if I had two different boxes or containers and they were different volumes, the gas would fill both equally. And that's indefinite volume. Now, if we were face to face, I'd say, class, everybody together, say out loud, what are the 3 states of matter? And if we were together, you would all together say solid, liquid, gas. And at this point, I'd say, oh, come on, you can do it better than that. Louder, everybody. And together we'd all do solid, liquid, gas. And you should know a solid has indefinite shape, indefinite volume. Indefinite volume, let me say that again. A solid has definite shape and definite volume. A liquid has indefinite shape, definite volume, and a gas has indefinite shape, indefinite volume. So if I said I put compound A into a glass and it takes the shape of a glass and it has a certain volume, you should know what state of matter it is, a liquid. Remember, solid, liquid, and gas. Or if I ask, name one of the three physical states of matter, you could put down solid, you could put down liquid, or you could put down gas. And if you notice, even on the slide I have, hint, know this. See how subtle I can be? Now, when we talk about matter, there are two types of matter, pure substances and mixtures. Again, when we talk about matter, there are two types of matter, pure substances and mixtures. So what is a mixture? You should know, switches on, these are things you should know. This chapter, there are a lot of definitions I'm asking you to memorize. Well, later on, the amount you have to memorize will come way down. Now, a pure substance is a type of matter that has a fixed or definite composition. Another way of saying it's composed of one type of atoms or molecules. My ring is made up of, I don't know if you can see it, gold. And gold is a pure substance. It's made up of atoms of gold. Now, molecules, the water in this bottle is pure. Hopefully it is. It's made up of molecules of water. And that makes it a pure substance. Now, there are two types of pure substances, elements and compounds. There are two types of pure substances you should know, elements and compounds. What's an element? Well, an element, and I'll never ask on a test what is an element, but you should know it's a pure substance consists of only one type of atom of an element. I really should change this. And a pure substance, another way of saying an element, cannot be broken down into simpler substances by chemical or physical means. And what does that mean? Gold, like my ring, or can you see the date? Yeah, it's when I got my bachelor's degree. That was a long time ago. But anyways, gold, I can't break this down to any other substances. I can't by chemical or physical means. Water, I can break down easily to hydrogen, oxygen, atoms, which become a gas when you do that, to something else. So my gold in here is a pure substance. If you had, say, sodium metal, a bar of it, you can't break it down into anything else by chemical and or physical means. And sodium is a pure substance. And all the elements on the periodic table are pure substances, like calcium, carbon, when it comes. Oh, by the way, Kr is krypton, and unless I've been kidnapped to another universe, in our world universe, krypton is not a green solid that will kill Superman. It's a colorless gas at room temperature, but it's an element because you can't break it down to anything simpler by chemical or physical means. Oh, it's time for a commercial from the management, me, Dr. White. Let's talk about the chemical symbols. I'll never ask you what is a chemical symbol, but it is a 1 or 2 letter abbreviation for the names of the elements. There's only the first letter is always capitalized. And if there's only 1 letter, it's capitalized like C for carbon. And if there's a second letter, like Na for sodium, the its chemical symbol, the first letter is capitalized, the second one is smaller case or lowercase. And I've only asked you to learn these 37 elements, what's their name and what's the symbol. You should know nitrogen is a chemical symbol Ni. Chlorine, the element, is a chemical symbol Cr. And argon, which I worked a lot with when I was getting my PhD and doing my PhD thesis, argon gas, its chemical symbol is Ar. So don't forget, learn these chemical symbols. And start on them now. Don't procrastinate. You're not going to learn chemistry a day or 2 before a test. You won't. I'll bet on it. Oh, I should mention something personal. If I say I bet on something, that means I already know I've won. So never bet with me. Now, there are 2 types of pure substances. One is an element, the other is a compound. And a compound is a pure substance that consists of a combination of 2 or more elements, always in the same ratio. Again, a pure substance is a substance that consists of a combination, these are compounds. It's a pure substance that consists of a combination of 2 or more elements, always in the same ratio. Another way you can say it's a pure substance that can be broken down into 2 or more simpler substances by chemical means. So an example of that would be water. Oh, I should mention, since, as I said earlier, there's no such thing as a dumb question in my class. If you can't read something I write on the screen, ask. What the heck did you just write? I tried to do it clearly, but ask that. Also, I have the fastest mouse wheel finger this side and the other side of the Mississippi River. And always feel free to ask, can you go back to that last slide? Then I should mention what you're seeing on the screen, the slides, is available in the lecture folder of Blackboard Chem 1105, and it's named Chapter 1. So water is a pure substance because I can break it down to hydrogen, oxygen, gas. Now, we have something else called mixtures. And mixtures are 2 or more substances that are physically but not chemically combined. Again, a mixture is when you mix 2 different substances together and they're physically but not chemically combined. What does that mean, not chemically combined? Well, let me pick on my water bottle again. I have water in here, a pure substance. If I were to take some salt, another pure substance, and pour it in here and shake it up, I'd have a mixture. The salt Sodium chloride, you'll learn later on, NaCl, doesn't change chemically. The water doesn't change chemically. If you wanted to, you could separate the two to get the salt and get the water separate. So that's a mixture. We have many mixtures, and I'll talk about that today in our life. So a mixture is when you have two or more substances that are physically, but not chemically combined, mixed together. That's why it's called a mixture. Profound. Now, when we talk about mixtures, there's two types of mixtures. I better be subtle again. And the two types of mixtures are a homogeneous mixture and a heterogeneous mixture. Now, what's a homogeneous mixture? That's a composition, a mixture where the composition is uniform throughout the sample. Later on, down the semester, we'll learn about this also called a solution. So homogeneous means the same throughout. And it's a mixture that's the same throughout. Now, what's an example of a homogeneous mixture? If I were to take my water bottle and put some sugar in there, shake it up, mix it, you'll see after a little while, it's the same throughout. It looks the same throughout. And if you were to analyze the liquid at the bottom or its top, it has the same mixture amount of sugar and water at that location. It's homogeneous. And that's a homogeneous mixture. And I could have done the same with salt and water. If I put some salt in here and mix it up, you would see it looks the same throughout. And that would be a homogeneous mixture. And if on a test, I ask, give an example of a homogeneous mixture, you could say water and sugar, salt and sugar. Now, not to scare you, but I will maybe just a little bit. Chemistry is all around you. I stole that from SpongeBob, and it won't hurt you to think about it outside my class. And in my room here, I have air. Yep, I do. I'm still breathing and alive. That's a good thing. Hopefully you are too. And the air is made up of mainly two different compounds. The air you're breathing is a mixture of oxygen and nitrogen gas. It's a mixture. I bet you didn't think about that. And if I walk over by my door, I'm not going to, the amount of air, nitrogen, and oxygen is the same as where I'm sitting here, because the air is a homogeneous mixture. It's the same throughout. So if you want to impress your friends, neighbors, and loved ones sometime, say, do you know the air you're breathing is homogeneous mixture? Don't, you lose friends. A lot of people don't like hearing chemistry. I learned that the hard way. I should warn you, I have a sense of humor and I use it. Sometimes I have good humor days. Sometimes, well, you and I both have to suffer through my humor. All right, so homogeneous mixture. It's the same throughout, a composition or mixture, the same throughout. Example would be air, water, mix, or sugar. I shouldn't say air, water and sugar, or air is an example of homogeneous mixture. Now, we also have what's called heterogeneous mixture. And a heterogeneous mixture is a composition or mixture that is not uniform throughout the sample. Heterogeneous, like heterosexual, two different, and that's a heterogeneous mixture. What would be an example of a heterogeneous mixture? Well, let's pick on my water bottle and water again. If I were to take this water bottle and put some sand in there, which I'm not going to, but if I did, what would happen to the sand? It would go all the way to the bottom. And no matter how well I shook it up, once I stopped shaking it, the sand would be at the bottom and up here would be just water. They're not the same throughout. It would be now a heterogeneous mixture. Another example of that is if you take oil and water, otherwise known as the oil vinaigrette dressing. If you've ever seen one like Wishbone, I make my own now. I used to do that. By the way, organic chemists are good ones, are good cooks, and I am both. But if you ever look at a bottle of Wishbone or other oil vinaigrette dressing, all right, everybody see the Wishbone Italian that I have highlighted? And you see the top is it's got two different layers. The bottom is a little darker brown and the lighter top. And that's a heterogeneous mixture. Bet you never thought about that. Salad dressing can be homogeneous or heterogeneous. Let's do another one. I got Wishbone or Kraft. If you look at the Thousand Island dressing, that's a homogeneous mixture. It's made up of a number of things. You can look at the ingredients label. Dr. White likes both. I make my own now. I don't buy these anymore. But those are examples. So if I were to ask you, give an example of a heterogeneous mixture, one example would be water and sand. That's going to be a heterogeneous mixture. Now, I just thought of another one for homogeneous. Next time you go by a gas station, the gasoline, that's a very complex homogeneous mixture. Not today, but tomorrow, I'll talk more about gasoline. I'll give you a little personal thing about what's the best gas to buy of the different brands of gas, because one company I worked for, that was CHEMI, I was section head of process and product development for all North America. It's an international company. And one of the things, we sold chemicals, additives to the petroleum companies, gasoline companies. And I got to go to their research center and talk to the different chemists. And I learned which is the best gasoline and still true, and what's the worst. And I'll teach you that tomorrow, free. No, actually, you have to pay to get my class. So another heterogeneous mixture, and do not try this. Oh, let's, yeah. is water and gasoline. You mix them, it'll separate. Another one, which I just showed you, of a heterogeneous is an oil. Oil, vinegar, vinaigrette, salad dressing. As I showed you with the wishbone Italian, it separates into two layers. No matter how hard you shake it, when you put that bottle down and come back a minute or so, it's going to separate. So there are two types of mixtures: homogeneous, the same throughout; heterogeneous, not the same throughout or uniform. Now, when we talk about matter, there are certain characteristics that distinguish one substance of matter from another. So there are certain types. Now, the first type is called a physical property. And I'll never ask on a test, what's a physical property? But you should be familiar with what is a physical property. And a physical property are characteristics of a substance that can be observed without changing the basic identity of a substance. In other words, they are distinguishing characteristics of a substance that can be used in the identification and description of a substance. Now, what are examples of physical properties? Hint, you should know this. And I do this because you can't read my mind. I hope not. But anyways, an example of a physical property, if we were at COD and I said, look out into the parking lot outside, if we were in HSC, it's a huge parking lot. You can see that's the building chemistry is in, Health and Science Center. And you'd see all these different cars or vehicles, and you could see they're not all the same color. I could say, how many red cars are out in the parking lot? Or how many blue cars, or yellow, or green, or pink? Once in a while, you'll see a pink car. And you could count those. That's a physical property of the car. Now, when we talk about chemistry, I'll teach you later on about a physical property you can measure. That's the boiling point temperature or the melting point temperature of a substance. And a physical property of water is at room temperature, like in my room right now, it's a liquid. At below 32 degrees Fahrenheit or 0 Celsius, centigrade too, it's a solid. And that's the physical properties of water. And what temperature do you have to take it to boil? 100 degrees C or 212 F. And that's a physical property of water. No matter where you get water from, it should always be those same physical properties. Now, we also have what's known as chemical properties. And chemical properties, and I'll never ask on a test, what's a chemical property? And by the way, you've got me as you've got this video as a witness. I said I won't ask it on a test or the final either. But a chemical property, and I'll talk about chemical properties this semester, is a characteristic of a substance that describes the ability of the substance to change to a new substance, So chemical properties describe how things can change their ability to form something new. Now, one example is rust. Hopefully you don't have any on your car. I have an older car, but I wax it a lot, so I have very little rust on it. Now, rust is a chemical property of steel. And that forms what's called ferric oxide, another chemical reacting with the oxygen here. Now, you can also have a stainless steel car. And the only one I can think of that's ever been made was the DeLorean, the car in Back to the Future movies. And that was made from a different steel that will not rust. Now, another chemical property is flammability. Water, why am I picking on water today a lot? Water in this bottle, if I put a flame underneath the actual water, it won't burn. It actually puts out the flame. Now, do not try this at home. Do not try this at home or anywhere else. Paper, which is mainly a certain substance. If I put a match under here, a heat source, it will burn. That's a chemical property of paper. Now, if I take gasoline, and do not try this, same thing, it's flammable. It will burn. Those are all chemical properties. And different things have different chemical properties, and they're important. So you should know examples of chemical properties. Another one is toxicity. If you drink water, like out of my water bottle, like I said, I'm picking on water a lot today, it's not going to kill me. Hopefully it won't kill you either. But if you consume certain chemicals, they are what we call toxic, and they can kill you. Please don't. So these are all examples of, I guess, an example of a chemical that's toxic is arsenic. Actually, it's an element. Now, when we talk about matter, we have two different types of changes we can talk about, how you can change matter. One type is a physical change. The other is a chemical change. And I'll never ask, what are the different types of changes in matter? And I say I won't ask, that means on a test or a final exam. Now, the two types are physical change and chemical change. Now, what is a physical change? Let me recenter this again. That's better. Oh no, my file's been attacked by the dreaded, I changed the centering bug or virus. No, it's not really. I don't know why I did that. But anyways, physical change. That's a process in which a substance changes its physical appearance, but this is important, not its chemical composition. I'll never ask what a physical change is. That's when it changes its physical appearance. In other words, one example would be a state of matter, physical state, but it doesn't change what it is chemically. Now, what are some examples you should know? Well, one example is when water melts. If you have ice, which is water as a solid, when it melts, it becomes a liquid. And if you've ever been outside or inside, you have a glass with ice cubes in it, and after a while, they're gone. Oh no, what happened? Well, they melted, and melting is a physical change when something goes from a liquid, ice solid, to liquid. Now, water, if you have liquid and boil it, you can have a physical change, because the water, when you boil water, it undergoes the physical change from a liquid to a gas. And if you're ever in the winter, overneath, if the room's cold enough where you're boiling the water, you'll see this vapor on top. We call that water vapor. That's really gas, water in the gas phase. So a physical change can be boiling water. And you should know an example. Now, another physical change I don't like this as well. If I ripped up this paper, it's not going to change. By the way, I should point out, when water melts, goes from an ice to solid, or when it boils, goes from a liquid to a gas, it's a physical change, but the chemical composition of water still stays H2O. It does not change, period. All right, so physical change, examples when it goes from one physical appearance to another, but doesn't change its composition, would be water going from ice to a liquid, a solid to liquid, or when you boil water, it goes from a liquid to a gas. Now, another example of a physical change, my liquid water, if I put it in my freezer, come back in an hour or two, I see it's a solid ice, it's gone from a liquid to solid. That too is a physical change. Now, there's something called a chemical change. And a chemical change is when an original substance is converted to a new substance that has a different composition and new chemical and physical properties. In other words, when something undergoes a chemical change, that substance is changed into another new substance. And that new substance has new chemical and physical properties. So what's an example? And again, I'm not going to ever ask, what's the definition of a chemical change? But I will ask, give the example of a chemical change. Now, one example, if you've ever seen those lighters, and by the way, Dr. White used to be a smoker, heavy smoker, decades ago. Thank goodness I gave it up back in about, well, I hate to say this, I think it was 1986 I stopped smoking. Thank God, or I'd probably be dead by now. But anyways, you have a butane lighter in a liquid that you click it and there's a spark and you'll see a flame. When you see that flame, that's the butane undergoing a chemical change to make other chemicals, water and carbon dioxide, plus heat, the flame. When you use a lighter, or if you have a Zippo, the same lighter, the lighter fluid is undergoing a chemical change. Now, not to scare you, but I will. When I was little, about 3 or 4, my mother used to say, chew your food well before you swallow or you'll choke. And guess what? She was telling me the truth. And I did choke once. In case you're wondering, I survived. But anyways, when you chew your food and swallow it, it goes into your stomach and your stomach breaks down the food you're eating, the carbohydrates, proteins, or fats and oils, undergo a chemical change and converted into other things. So I hate to scare it to you, but the next time you have breakfast, lunch, or dinner, or a snack, the food, have to do what my mother taught me, chew it well before you swallow or you'll choke. And she was right. It goes into your stomach and undergoes a chemical change into new things. An example, when you eat a protein, your stomach starts breaking it down into what we call amino acids. That won't be on the test. But this chemistry is all around you. When I eat, when you eat, when you breathe, the air is used. I'm not going to get into everything, but those are examples of a chemical change. Another one, I have a really beautiful collection of candles I got from when I was in Europe. I don't burn them. I'll buy stuff here in the United States, but these were hand dipped candles and they're huge, big diameter. And when you burn a candle, the wax, which is pulled up into the wick, reacts with the air to form a flame, but the wax undergoes a chemical change. Now, in this chapter, they have an area called temperature. And I'll never ask you what's the definition of temperature. Temperature is a measure of how hot or cold a substance is compared to another substance. Another way of thinking of it is temperature, the concept, heat flows from a substance of a higher temperature to a substance of a lower temperature. And heat is a form of energy. Now, when we talk about temperature in this class, we use different scales. First one is Celsius, and that's abbreviated by either this symbol or this symbol. I'll never ask you on tests, what does that symbol mean, but I'll use it. Mainly the degree circle plus the letter. Now, I did it earlier today and I caught myself. When I learned this, it used to be called centigrade. About 20, 30 years ago, they changed to Celsius, the name of the scale. But once in a while, it'll still pop out wrong out of my mouth. Now, there's another scale called Kelvin, and that's abbreviated by K. And Kelvin is an absolute, so you don't say degrees K, you just say K or Kelvin. And the final one is Fahrenheit. And if you're in the United States, we use mainly Fahrenheit from our weather reports, even though you can go by and drive on the street and see bank signs that give both Celsius and Fahrenheit temperature. And that's degrees F. If I look at the clock, oh no, we're almost out of time. Time flies when you're having fun with me, I hope, and chemistry. Now, let me remind you, tomorrow we'll have our first lab. And if you don't have your lab kit yet, that's okay. You'll need it the following week or so. And even if it's a little late, I know sometimes there are problems getting the kit on time. We'll work it out. If you haven't figured out by now, I am a laid back, easygoing person. I'm not going to say, oh, you forgot the period after that. I'm going to take off 10 points. That's not me. But anyways, tomorrow we'll have our first lab at 10. Sometime later this afternoon or by tomorrow morning, say by noon tomorrow or earlier, I will have a video of today's lecture on my 1105 YouTube channel. You can find a link to that on Blackboard or in my syllabus. Now, one of the things I should mention, I'm Jewish, and I am. And there's a language called Yiddish. It's a mixture of German and Hebrew. And my grandparents, which all came from Russia, knew Yiddish. And when I was little, my grandmother, my mother's mother, my other grandparents, my grandfather and were really nice, but this one woman, Bessie Greenman, my grandmother, was probably one of the finest people I've ever met in my life. My parents were great people, but she was something so special to me and a lot of other people. And whenever we'd leave, she would say "Gang gesund." And "Gang gesund" means go in health in Yiddish, which is a good blessing or good thing to say. And since the pandemic, when I've been teaching either face-to-face or especially here on Zoom, I will say "Gang gesund" when I end the class, and I'll also use this, goodbye. And I stole that from Beverly Hillbillies Granny. At the end, Granny would do that when she'd say goodbye. So with that, we're done for today. and I'll see you tomorrow. Gang gesund, and I'll see you tomorrow.